Let's work with the half angle identity. We want to find the exact value of the cosine of 15 degrees using the half angle identity for cosine. Well, the first thing to note, if we're going to use a half angle identity, is that 15 degrees is exactly 1/2 of 30 degrees. And so we're looking at the cosine of a half of some angle. The next thing to note is that 15 degrees is in quadrant 1, and so we can use positive the square root of 1 plus the cosine of 30 degrees, all of that over 2. Positive because 30 over 2, or 15 degrees, is in quadrant 1, and cosine's positive there. Now what we need to do is put in the cosine of 30, which is the square root of 3 over 2, and we need to simplify. Within the radical, I can multiply the numerator and denominator of the fraction in the radical by 2. So here's what I'm going to do. And so in the radical, I have 2 plus the square root of 3 over 4. Now the denominator, the 4, has a square root. Its square root is 2, but we'll leave the numerator as the square root of 2 plus the square root of 3. And this is the exact value of the cosine of 15 degrees. Let's use a half angle identity. We want to find the exact value of the tangent of 22.5 degrees using the identity that tangent of an angle over 2, or half of an angle, is sine of that angle divided by 1 plus cosine of it. Well, to work with this particular problem, if we're looking for the tangent of 22.5 degrees, 22.5 is exactly half of 45. To use this identity then, we'll find the tangent of 45 degrees over 2, which is the same as 22.5. Well, that means for A, in my identity, I can put 45. So I'm looking for the sine of 45 degrees divided by 1 plus the cosine of 45 degrees, and I need to simplify after putting in those values. The value for the sine of 45 degrees, and let's continue over at the far left here. The sine of 45 is the square root of 2 over 2, and so is the cosine of 45. To clear the 2's, the denominator 2 in the fraction, the big fraction, I'm going to multiply the numerator and denominator by 2 to get square root 2 over 2 plus the square root of 2. And now I want to rationalize the denominator, so I'm going to multiply the numerator and denominator by 2 minus the square root of 2. And that'll give me 2 square roots of 2 minus 2 over this denominator multiplied out. And probably it'd be a good idea to stop right here and work this out on a separate sheet of paper. Okay, so let's get started. We need to multiply square root 2 times 2 minus square root 2 and 2 plus square root 2 times 2 minus square root 2. In the numerator, if I distribute, I get 2 square roots of 2 minus 2, which is square root 2 times square root 2. In the denominator, if I multiply that out, using the fact that it becomes a difference of squares, I end up with 4 minus 2. Now, continuing to simplify, I'm going to factor a 2 from the numerator, and I have that times square root 2 minus 1. 4 minus 2 simplifies to 2. I'll simplify 2 over itself to 1 and end up with square root 2 minus 1. And I need to conclude then that the tangent of 22.5 degrees is the square root of 2 minus 1. Let's work with some half angle identities. Given that cosine s is 2/3, with s between 3 pi over 2 and 2 pi, we want to find the cosine of s over 2, we want to find the sine of s over 2, and the tangent of s over 2. Let's start with the cosine. To find the cosine of s over 2, what we know is that the cosine of s is 2/3, and that s is in quadrant 4. Now the cosine of s over 2 could be either positive or negative. We need to make a choice. Square root of 1 plus cosine s all over 2. If s is in quadrant 4, 1/2 of s is going to be in either quadrant 3 or quadrant 2. In either case, this is going to be negative. So to continue with this, I'm going to use negative the square root of 1 plus cosine s, which is 2/3, all divided by 2. And to simplify, I'll multiply the numerator here by 3 and the denominator by 3 within the radical, and have negative the square root of 3 plus 2 over 6, which is negative the square root of 5 over 6, and I should rationalize that denominator. I'll keep the square root of 5, but multiply the numerator and denominator by the square root of 6, and end up with negative square root 30 divided by 6 for the cosine of s over 2. Well, let's continue and find the sine of s over 2. I want to find the sine of s over 2. I know the cosine of s is 2/3, and s is in quadrant 4. I have two choices. I have either positive or negative the square root of 1 minus cosine s all over 2. Well, if s is in quadrant 4, half of s is going to have to be in quadrant 2 if you think about having an angle that ends up in quadrant 4. In quadrant 2, the sine is positive, so I'm going to use positive the square root of 1 minus the cosine of s, all divided by 2. And I want to simplify by multiplying the numerator and denominator of the fraction within the radical by 3 to get positive the square root of 3 minus 2 over 6, which is positive the square root of 1/6, which is 1 over the square root of 6, which if we rationalize the denominator, ends up being the square root of 6 over 6. Well, let's continue. We also want to find the tangent of s over 2. We found the sine and we found the cosine. To find the tangent, let's put the sine of s over 2 over cosine of s over 2. So we're going to put square root 6 over 6 all over negative square root 30 over 6 and simplify. If we multiply by the reciprocal, we'll have square root 6 over 6 times negative 6 over the square root of 30, and the 6's will simplify. And I have negative square root 6 over square root 30. Again, we want to rationalize the denominator, so we're going to multiply the numerator and denominator by the square root of 30. And we'll end up with negative the square root 6 times the square root of 30 is the square root of 180, all over 30. The square root, or 180 itself, is 36 times 5. Just continuing to simplify, and the square root of 36 is 6. So this ends up being negative 6 square roots of 5 over 30. But 6 and 30 simplify, a factor of 6 simplifies, and so we end up with negative the square root of 5 over 5 as the tangent of s over 2. Let's work with some half-angle identities. We want to simplify positive and negative the square root of 1 plus cosine 12x divided by 2. The cosine half-angle identity, cosine a over 2, is plus or minus the square root of 1 plus cosine a over 2. If we let a be 12x, we have exactly the right-hand side. So what we have should be equal to, working right to left, the cosine of 12x over 2, which simplifies to the cosine of 6x. Here's another part to this example. Let's simplify 1 minus cosine 5 alpha over sine 5 alpha. Where there's a tangent half-angle identity, tangent a over 2 is 1 minus cosine a over sine a. And what we are given and asked to simplify matches the right-hand side of this identity exactly, with a equal to 5 alpha. So if we work from right to left, we can say that what we have is the tangent of 5 alpha over 2 and stop at that point since that doesn't simplify. Let's work with some half-angle identities. We want to verify that sine of x over 2 plus cosine of x over 2 all squared is equal to 1 plus sine x. Well, what I'm going to do is go ahead and square the left-hand side. I'll have sine squared of x over 2 plus twice sine of x over 2 cosine of x over 2 plus cosine squared of x over 2. And I'm going to apply a couple different identities. First of all, sine squared of something plus cosine squared of the same thing will add to 1. So this term plus this term add to 1. For 2 sine x over 2 cosine x over 2, I'm going to apply a double angle sine identity. That's equal to the sine of twice x over 2. So all of this is within the sine. Now the 2's simplify, and I end up with 1 plus sine x, which is what I was trying to show that I had, and I verified that identity.